Right, good morning, everyone. Please get into the habit of putting your camera on if possible, because as I said yesterday, it will be better to be able to see your faces. Okay, as usual, the way we start is I ask you questions about your homework. How did it go? Do you have any questions? And after that, we start the new material. Okay, so how did the homework go? Do you guys have any questions about it? Good morning, Freddie. Did you fix your camera? Okay, questions about the homework? Anybody? Okay.
I couldn't figure out 2E.
2E. Okay,
Yeah.
we can do that. All right. Okay, so let's start by doing this, and then we go through the start integration by point. So we're gonna do number 2. And I see 2 questions. We're gonna do both. So the first one is D, and the second one is E. Okay. So we have to find the antiderivative of the following: x times cubic root of x plus the fourth root of x dx. Okay. All right, so it looks a little bit complicated when we look at it, but let's see what we can do. First, what we cannot do. Okay, what we cannot do is take the x out. Why we cannot take the x out? Question number 1. Question number 1, why? So my first question, can I pull the x?
No, isn't that because of that multiplication rule?
Yeah, what does it say?
Because it's not a constant.
Right, absolutely right. I cannot do that. X is not a constant. The only thing you can pull out of your integral and constant and only constant. So this is nonsense, absolute nonsense, because x is a variable. All right, so the only way we can do that is by distributing. Nowhere else. We have to distribute to make it, rewrite it so we can use whatever we know. So let's do that. So this is x cubic root of x plus x the fourth root of x dx. Okay. Now we have a sum. Now when we have a sum, we can split. Only a sum could be split. So we can split it into this. Okay. All right. So this is equal to what? Now let us see here. This is product. X times another function. Now, again, what we cannot do is split the product. It means this cannot be split into the integral of x times the integral of that. So a product cannot be split. So the integral of, if you multiply 2 functions, you cannot split it. This cannot happen. Okay, so this is absolutely wrong. So we have to deal with that. So what's the best way to deal with this? The best way to deal with it is cubic root of x, rewrite it as x to the third dx. And this one, we're going to do exactly the same. Right? And now, x times x to the power a third, we use the law of exponent, is x to the power 1 plus a third. That is x to the power 4/3. So this is going to become x to the 4/3 dx. And I'm going to do exactly the same here. 1 plus 1/4 is 5/4 dx. Now we really have it simplified in a way that we can use the power rule. So this would become 1 over 4/3 plus 1 x to the 4/3 plus 1. So from here to here, my n is 4/3 plus 1 over 5/4 plus 1 x to the 5/4 plus 1 plus our constancy. So find is equal to 4/3 plus 1 is 4 plus 3/3. That's going to give me 3/7 x to the power 7/3 plus 5/4 plus 1, which gives me 5 plus 4, 9/4, 4/9, x to the power 9/4 plus a constancy and of the problem. Okay. So we cannot make up our own rules. So we have the very specific rules that we have to use, and we cannot really make them up. We have to follow them verbatim. Right, so now we're gonna look at the, which one, E, you guys asked about, and then we proceed. All right, E, what does it say? We have to find the antiderivative of y plus 5 y to the power 7 over y to the 3 dy. Okay. So again, let's see how we can do that. Okay. So, I mean, I'm listening. I'm just being calm. How?
Separate them into two different fractions, y over y to the third.
Exactly. Fractions is like product. I cannot do anything. It means if I have integral of f over g is definitely not that. You cannot split the integral. I mean, sorry. You cannot split the integral. I mean, those rules make nonsense. So we have to manipulate to be able to come up with something we know how to do. So one way to manipulate is, this is a fraction and we have a sum. So this will become y over y to the power 3 plus 5 y7 over y to the power 3. So we can, that's a numerator, and numerator can be split. So we can split a numerator, but we cannot do is a denominator. Now the rest become a little bit simpler. Y divided by y over 3, that's 1 over y squared plus y7 over y3 is y to the power 4 dy. At this stage, the problem is becoming fairly simple. Okay, so finally this is equal to y to the negative 2 plus y to the 4 dy. Equal to. And now we have to do that. Antiderivative of y to the minus 2 is 1 over minus 2 plus 1, y to the minus 2 plus 1 plus antiderivative of the other term. This is a sum, so we're splitting. So antiderivative of the first plus antiderivative of the second. 5 is a constant. I don't have to worry about it. Y over 4 is 1 over 4 plus 1, y to the 4 plus 1. So now I'm there. Minus 2 plus 1 is minus 1. So I will have minus 1. 4 plus 1 is a 5, and the 5 kind of simplify, and then I will have plus. Now, if you want, you can check your answer by differentiating this term. That's how we check. And we make sure that we get what the term inside the integrand. So actually, if we differentiate this, we get derivative of minus 1 over y. Minus 1 over y is minus y to the minus 1. So the derivative is minus times that y to the minus 2. So this is 1 over y squared plus 5 y to the power 4. Okay, so finally, if I find a common denominator, I will have 1 plus 5 doing something wrong here. No, sorry. Plus 5 to the power 2 and 4, that's give me 6 over y squared. Okay, which is this the same thing as the integrand? So let's see, the integrand was y plus y7 over y cube. Are those the same? So I differentiated my answer. I got that. Is it the same as this?
Yes.
Yep, absolutely. Because this is, both are, like, I mean, here you can simplify by y. You get y plus 5 y6 over y squared. Simplify by y. Okay. Otherwise, I'm doing something wrong. Very good. All right. Now I still have one answer from chat for number 1. I got something, but I'm not sure, please. Okay, I will do that. Number 1. Okay, we'll look at number 1. Is it the, which one, which number 1 you mean?
And he means 1A.
You mean 1A? Okay, thanks. So we're going to look at 1A because we're not allowed to forget how to find derivative. So let's look at number A. The 1A, sorry. So I have a function and we need to find the derivative this time. So f of x equal x to the power 4. I meant x to the power 3 plus 4 over the square root of x plus 2 ln of x plus y squared. Okay, so very good. So let us find the derivative. F prime. Okay, to find the derivative, we can do that. That's easy. 4 over root x, we should rewrite it as to the minus a half. And this is easy. And this is easy. So I prepared it before I hit the derivative. Okay. So what's f prime? Derivative of x cubed, 3x squared, plus 4. Derivative x to the minus a half is minus a half x, the minus a half minus 1, plus derivative of 2 ln of x. 2 is a constant, drop it. Derivative of ln is 1 over x, plus pi squared is a constant. Pi is a constant, 3.14. Squared is still a constant. The derivative is 0. So f prime is 3x squared minus 2x to the minus 3 half plus 2 over x. Okay. I will do one more and then we proceed for the integration by substitution. So I will do part B, again, just to remind you, and then we stop. So part B is, we have the function f of x equal cosine 5x times e to the x squared. Check x of x cube x squared. Okay, so let us remember how to do that. First, that's a product of two functions. We have to use the product rule. So let's see what the product rule tells us. It's the derivative of the first term times e to the x squared plus cosine 5x times the derivative of ax squared. Okay, so product rule immediately. Now, once we do the product rule, now we have every piece by itself. Okay, what's the derivative of cosine 5x? Get going quickly. And which rule do we use?
Chain rule.
Chain rule. You have to use the chain rule. So what's the derivative of cosine 5x? We have it outside is the cosine, the inside is the 5. So that's my inside function. So it's the derivative of the outside of cosine, which is the minus the sine of 5x, times the derivative of your inside, which is 5, times EX squared, plus cosine 5x times, again, e to the x squared, that's a chain rule. That's my inside function. So that's here, my inside. And the outside is the exponential. So it's the derivative of the outside. Derivative of e to the u is e to the u. But when you evaluate it at the inside times the derivative of your inside, which is 2x. Okay, crucial to remember those. Crucial to remember, especially the chain rule. Okay. All right. Any other questions? Fine. So today we keep our review process. I'll keep it for a little so you guys can copy. So we're going to review the integration by substitution. Okay, so let's get going. Any question before I proceed? Okay. So integration by substitution. Again, that's the second review for this course. By substitution. So let us see what the issue is and how we're going to remedy this issue. So here's the idea. If I ask a simple question, what's the antiderivative of cosine x? So we know that. It's the sine. Why it is the sine? Because when I take the sine and differentiate it, I get cosine. Okay. Now, what if I put, instead of cosine x, I put cosine 4x dx? The question is it this equal plus c? True or false? Okay. True or false? Let me ask one of you. Natalia, what do you think?
False.
Because? Because? I'm listening. Natalia? Or it's false? Anybody?
Because you have to account for the 4x on the inside.
Yeah, because the derivative of sine 4x is what? What's the derivative? Derivative to the outside times the derivative of the inside, times 4, which is definitely what I don't have here. I have only cosine 4x. So the derivative of the outside is not cosine 4x, it's cosine 4x times 4. So this definitely is false. So I have an inside function. Whenever I have an inside function, problem becomes complicated. So if I had, however, the following picture, a very simplistic picture. If I had cosine 4x times 4 dx, so I have a function, I have an inside, and the derivative of the inside is also part of the integral. This will be exactly the sine 4x because of this reason. Okay, so let us really look at this integrand here. That's the piece I want to start focusing on. What's this integrand is, and why did we get sine 4x? This integrand is very specific. This integrand has the following form. So the integrand has the following form. there's an inside function for x, and the derivative of the inside is part of the integral. So this integrand has the following form: f of g of x times g prime of x. Very, very specific format, where g of x is the 4x, and the outside function is the cosine function. So the integrand here has a very specific format. It's f of g times g prime. I have an inside, and I have the derivative of the inside as part of the integral. Whenever the integrand have this form, there's an inside, as the derivative of the inside as part of the integral, we use a technique called substitution to find the antiderivative. So whenever
I have a question.
I'm listening.
Is that f of x just x? I
No.
can't tell because of the little squiggle.
Cosine. F of x.
Oh, that's cosine? Okay.
Yes, yes, thank you. So I will erase it, thanks. It's the cosine. You understand why though?
Yes.
Yeah, so the outside is the cosine and the inside is the 4x. That's the
All right, thank you.
Now, whenever the integrand has the form, whenever the integrand has the form, this form, f of g times g prime, so it's very, very specific format, we use a technique called substitution. Called substitution. Okay, right? So because in this problem, we kind of guessed sine for x because of course it was clear from the problem, but a lot of time we cannot really guess as easy. But whenever the integrand have this very specific form, f of g times g prime, means I have an inside and the derivative of the inside is part of the integral, we're going to use a technique called substitution. And let us review how does this technique work. So we're going to do several examples to review the technique. So example number 1 is this one. Again, I'm going to do it again using the technique called substitution. So example number 1. So evaluate the following. Integral of cosine for x times 4 dx. As you realize, I'm not really changing the integral. So how do we proceed? Proceed as follows. First, we're going to introduce a variable, a new variable called u. So we introduce a variable called u. And we usually let u to be the inside function, or we let u to be the function whose derivative is part of the integral. And in this case, for x is the function whose derivative is part of the integral. So we introduce a function, a new variable called u, and we set u to be for x, the inside function. And then we find the derivative of du. Remember, this is a function, the derivative with respect to x is equal to 4. Okay. Now we multiply by dx. So multiply by dx formally. Dx formally. And I will get du is 4 dx. Okay. Now, we substitute, and that's the crucial part. Now, we substitute. We substitute everything, and I'm going to write everything in capital letter. Because we substitute everything in the integrand inside the integral in terms of u. The first problem, I do it in a lot of details. Everything. And when I mean everything, I really mean everything. So let's see what I'm talking about. So, integral of cosine for x times 4 dx equal to everything, and I mean it everything, equal to 4x is the u. So cosine 4x will become the cosine of u times everything. Now, when we do substitution, actually, I tell my student, now you have always to watch this. So for dx, according to my work, this piece for dx, so this is the cosine of u, for dx is actually my du. Everything. I mean, x should not remain in here. Everything has to be in terms of u. Once I do that, I take this integral and I evaluate it as an integral in u. So now we evaluate as an integral in u. As an integral in u alone. So now I have a new integral where the new variable is u. So I forget about x a little bit. Now that's a new variable u. Now antiderivative for cosine u, we know that. That's the sine of u plus my constant. And now at this stage, once I evaluate this as an integral in u, we go back to x. And now we go back to our original variable. Original variable x. Okay, let's do that. So it's be equal to sine of 4x plus and of the problem. Okay, so whenever the integrand has the form f of g times g prime, kind of, then we use substitution by setting q to be the inside function or u to be the function whose derivative is part of the integral. We compute the du, and then we substitute everything in terms of u, verbatim. We create an integral in u. We evaluate it as an integral in u. We find it, and then at the end, we go back to our original variable, which is x. Okay. And so now we're going to practice this substitution. We're going to do a lot. We're going to spend the whole time just doing problems that deal with substitution. So problem number 2 is the following. Evaluate integral of something like 3x squared times x4 plus 6 to the power 5 dx. Of course, the problems are made up very well, so substitution will work. So they are made up, so they have to be made up correctly. So I'm going to switch to x cubed. Okay, all right, very well. Now I look at this integral. Do I see an inside function? And I see a function whose derivative is part of the integral. I mean, do I see a function, an inside, whose derivative is part of the integral? Very quickly, very quickly. So, of course, everybody is telling me, so what's going to introduce my variable? What's going to be my variable u here?
X cubed plus 6.
X cubed plus 6. It's just basically staring at us in the eyes. The derivative of it is part of the integral. So now the du dx is 3x squared, then du is 3x squared dx. And now everything in terms of u. So I'm going to take this integral, rewrite it here, and substitute everything in terms of u. Equal to, very well. In terms of u, so every piece, as I said, everything. This is very clear. That's my u to the power 5 times. And sometimes they are not written in the order we want, so we have to be careful. 3x squared dx. 3x squared dx is going to pick the du. And now I am done. That's an integral in u. I evaluate this as an integral in u. Let's see. That's a new integral. U is my variable now. Once I do that, my last step is go back to x. X cubed plus 6 and to the power 6 plus. All right. Now the last step is we check just to make sure that we're not goofing. Means I find the derivative of this term and I make sure I get my integrand. That's equal to 1 over 6 times chain rule. As you realize, the integration by part, sorry, the integration by substitution, it's basically reversing the chain rule. So by the chain rule, the derivative of this is 6 times x cubed plus 6 to the power 5 times the derivative of the inside, which is 3x squared. Those simplify, and I get exactly x cubed plus 6 to the power 5 times 3x squared. And I am on the right track. Okay. Now notice how delicate the substitution is. If I had put 3x cubed times x cubed plus 6 to the power 5, I cannot go far with substitution. Substitution becomes very, very hard because the derivative of x cubed plus 6 is not really 3x cubed. So this will have to be done in a very totally different approach. So it's a very, very delicate situation. Problem number 3 is again substitution with a little bit of alteration, a little bit of a change. It's not really a big deal. So let me do the following. Integral of w, let us say, I'm tired of using x, antiderivative of w squared minus 5 dw. Okay, so again, we're going to do that substitution. What's the natural substitution to do? And I know we have an issue, but we will take care of that. What would you like to do?
Make u what's inside the square root.
We're going to make u to be what's inside the square root. So we're going to make u to be w squared minus 1, right? Now what's the derivative of u? So I'm going to do exactly what you guys suggested. Minus 5, okay? And then the du, dw is 2w. So the du here, my apologies. So the du is 2w dw, okay? Now outside I only have w, so I don't have the whole derivative of w squared minus 1, but I have part of it, w. But this is not really an issue because the difference is a constant. So we don't have to worry about that. We will see how to take care of the situation. So the derivative of the inside is not quite there, but it's almost there because there is only 2 as an issue. So how do we take care of this? All right. I go back here and I said, all right, I want to express everything inside in terms of u. One part is easy. So this become u, the square root of u. No question asked. Now, the w dw, this is where the du has to be used. I don't quite have it. Du is 2w, but I'm going to remedy for that. I said, you know, I want w dw. I only have 2w. So we remedy for that by dividing by 2 at this stage. Remember, du and dw mean a little bit of w. W dw. So that's how we remedy for the lack of having that. So I'm going to divide this by 2 so I can pick up the w dw, which is not really very hard. So finally, I'm going to have square root of u, w dw is a half du. I'm done almost. Now I have an integral in u, which is easy. A half is a constant. I can pull it out. And then I will have u to the power a half du. And this will give me a half, 1 over a half plus 1, u to the half plus 1 plus c. So finally, it's a half times 1 over a half plus 1 is 3/2, which gives me 2/3, u to the power 3/2 plus c. So finally, I will get 1/3 u, I have to go back to x, which was w squared minus 5 plus and of the problem. Okay, so even if I didn't have quite the derivative of the inside, but as part of the integral, I have it up to a constant, and this is never an issue. If you have it up to a constant, it's really never an issue. Can I move on? Okay. So now let us take the following.
Can you go back real quick? I just need to see the answer. One more
This
time.
one? Yeah.
Yes.
Now we're going to consider the following integral. As I said, we're going to do a lot with that.
All right. Thank you.
Let us evaluate the following integral of simply square root of 1 plus 2x. Okay, quickly. What's your u? Actually, I'm going to give you 3 minutes to do it yourself, and then I will pick up from there. Get going, do it. Please put your camera on. It helps me a lot. Okay, are you ready? Matthew? Ready?
Oh, I didn't finish it yet.
What was your u?
Oh, for the u, I put what was underneath the square root.
So it is 1 plus 2x.
Yes.
All right. So what's your du?
The du.
Mhm.
Wouldn't it be 2x?
No,
Or
no.
no.
Let us
All right.
remember. Let us remember slowly. We find du dx. If you ever forget. Du dx is the derivative. Okay? Derivative of 1 is 0 plus the derivative of 2x is just 2. All right? Means that the du multiply formally by dx, you get 2 dx. Are you with me?
Yeah.
Very good. So now we express everything here. Is equal to. We don't see the 2 here, part of the integrand, but this is not a big deal because it's a constant. So this will give me the square root of u, this piece. Now I have the dx. As I said several times, everything in terms of u, you have no choice. What's the dx? Now, usually I tell my students you have to have always, we have 2 eyes. We keep one eye here and one eye here. So to put things together. The dx, I have to find it in terms of du. Dx means represent the delta x. So it's really a quantity. It's something very, very tiny. So that's how you look at it to be able to interact with the substitution. What's the dx? To isolate the dx, I have to divide by 2 here. So a half du is my dx. So my dx here become half of the du. Okay. So now this is equal to, a half is a constant, I can pull it out. The square root of u is u to the half du. Right? So this is going to be equal to a half times integral in u now. I just evaluate it as an integral in u. 1 over a half plus 1, u to the half plus 1, plus c. So finally, I will get a half. A half plus 1 is 3/2, 2/3, u to the power 3/2 plus c. Now those two simplify. I will have 1/3 u 1 plus 2x plus c. So anybody who got that answer, you are on the right track. Okay. So remember, to find the du, you need first du dx, means the derivative of that. So the derivative of that, the derivative of 1 is 0, plus the derivative of 2x is 2. So the du is the 2 dx. Okay. Another one and 2 more at least, so you guys will be comfortable with that. Evaluate the following integral of something like sine x over 1 plus 5 cosine x dx. Again, I'm going to give you a little bit to interact with that, and then I get back to you. Get going. Try to see it. Try to connect dots. Try to connect dots. Do you see a function? Do you see its derivative? And so on and so forth. Yeah, I'm going to pick one of you to help me out. All right, so okay, I'm gonna pick one of you and see what you got. Jason H. Hoxima, I guess. Are you ready? Jason, are you ready? Tell me yes or no. Okay. Ian Wall. Ian, are we ready? Okay, who's ready? Who's ready?
I can do it.
Sure, go ahead. What do you think your u is going to be?
So I put 1 plus 5 cosine x for u.
Yeah. Why this is a good idea?
Because the derivative of that is approximately sine of x.
Right. By putting q, which is always a very good trick, put part of the denominator to be the u, and we can do that because the derivative is almost the sine of x. So that's a very good choice. So we actually see the derivative there. It's the sine up to a constant, but I say a constant should never really give us any issue. So u is equal to that. So now we have to go after the derivative. So what's the derivative here? Derivative of 1 is a 0 plus derivative of 5 cosine x is a 5, and there is a minus here, the sine of x. Okay, so this is gonna give me, now I isolate my du. My du is minus 5 sine x dx. Okay, now I stop here and then I go back and do substitution term by term inside my integral. So this will give me, this is equal to integral of. All right, so let's see how I'm gonna manipulate that. The denominator is a u, there's no issue with it. Now what about the numerator? The sine x dx. And then this is where I have to start keeping my eye on both those. So what's the sine x dx? From here, I need basically to isolate only the sine x, which is not a big deal. I divide by minus 1 over 5. I will get minus 1 over 5 times du, so that's a multiplication, is sine x dx. So it's really, again, right there. So the sine x dx become minus, so that's a 1, minus 1 over 5. So we are fine. We have an easy integral in u. So finally, minus 1 over 5, that's my constant. I can get it out. 1 over u du. So it's will equal to minus 1 over 5 times antiderivative of 1 over u. Let us remember that's the natural log of u. Let's see. So this will give me, now I have to go back to my original variable, ln. The ln of the natural log of u, it means of the sine x plus my constant c of integration. And
1 plus 5. 1 plus 5 cosine x is u.
thank you very much. My apologies. Thank you very much. 1 plus 5 cosine x plus and of the problem. Okay, let's finish with one problem along those lines. And please, I would like you to participate. Please, when I'm working, work with me. That's how it's going to help you a lot. So my last problem, and then hopefully substitution will be clear. Let us say it's a little bit harder, but it's not actually very hard. It looks complicated, but it's not. E to the power the square root of x, the whole thing divided by the square root of x dx. Yeah, I'll let you a little bit interact with it. Every one of you should be able to handle it.
Professor,
Yes. Go
should we
ahead.
rewrite the should we rewrite the equation to put that denominator as x to the negative 1/2?
Yeah, I mean,
Or is that not thinking correctly?
so you want to write it this way. Let me make sure
Okay.
I'm understanding. That's what you want. That's what you want to do.
Yes, is that correct?
It's fine. Yeah, I mean, that's mathematically correct. There is no issue with that. Yes. But still, we have to find the u. I want you to connect that a little bit. It's a substitution problem. What do you think is going to be the natural u?
Square root of x.
Yes, why? Who can give me a reason that is, who can give me why u equal root x will be a good choice?
It's not the same as e to the x. Like if you took the derivative of e to the x, it'd still be e to the x, but e to the square root of x, you gotta take it further to get the answer.
Right.
So that was my
Basically,
thinking, at least.
yeah, at least my thinking, I want to give you something very simple thinking in my case, that I don't know how to deal with root x as the power of e. As simple as that. So I really want to, it's such a complicated term. I said, okay, let me try to take care of it and put it my u. Now, of course, the problems are made so they work ahead of time. So whenever I have an inside function, this is really a complicated inside function, the root x, very complicated inside function. As you said, as your classmate said, it's not e to the x, it's the square root of x, very complicated inside function. I said, let me go ahead and put it my u and hope for the best. So now let us finish. Does it work? What's the du? First, I'm going to find du dx. What's the derivative here? So square root of x is x to the half. The derivative is a half x to the minus a half. Am I right? Okay. Now I multiply verbatim by dx. So remember dx, think of it as a quantity, as a little bit of x. So otherwise you'll be very confused. Dx. Now I have to stop and go back to my original integral and see, is the picture there? So let's use equal to what? And then realize it's done. E to the root x, that's e to the u. And now let's see what's left. X to the minus a half dx. And now I watch. I want to substitute this in terms of du. As I said, whenever you have substitution, you really look at two things. So now if I look very carefully, x minus a half dx, I almost have it there. So I need to multiply by 2 both sides, the du, to be able to get x to the minus a half dx. So I multiply, I will get 2 du is x to the minus a half dx. So basically the derivative of the inside was in front of us. We didn't see it because it's a square root of x, which is, we haven't memorized its derivative. So this is going to give me, so this piece would be 2 du. That's my integral in u. It's basically a simple one. So that's 2 times integral of e to the u du. It means 2 eu plus c. And finally, I go back to my x plus c. Okay. Now we check our work. Equal to 2 times derivative of e to the root x is derivative of the outside evaluated at the inside times the derivative of the inside plus 0. So equal to 2 times e to the root x times the derivative of the square root of x So we've did it a minute ago. Square root of x is x to the half. The derivative is a half x to the half minus 1, which is that. So this will give me a half x to the minus a half plus a 0. The two simplify, and I'm left with e to the root x. X to the minus a half is 1 over the square root of x, which is exactly the integrand we're looking for. Okay, so again, substitution was not far-fetched in this problem. Having square root of x as an inside really was the key, that this is such a complicated function to deal with. So we set it to be my u, and we hoped for the best. All right. So that's it for today. For the review, please finish the worksheet I gave yesterday. This all substitution. Tomorrow, we will review the Riemann sum, definite integral, and then we start chapter 6-2, hopefully either Thursday or Friday. All right. Any questions before we go? All right, great. Bye-bye, guys. See you tomorrow.
Professor.
Goodbye.
Bye.
Have a good day.
Thank you. Bye-bye, guys.